everyone, thank you so much for coming to this lesson. So today we're going to be learning about parametric equations and modelling. So this is going to be a continuation on last video where we were learning about parametric equations. So make sure you fully understood everything we did there before you come to this video. So the learning objective for today is just to be able to use parametric equations and modelling, and we're going to be doing 2 example questions to show you how this can be done. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any part you want to. So if you remember what we did in the lesson about functions and modelling, we learned that model is just a simplified version of reality. So we can use modelling with parametric equations as well, and this could be really useful when we're working out the distance of something, for example, in the x and y direction of coordinates. So we have an example here, and it says a flying disc is thrown from the point 0, 0. After t seconds, it has travelled x meters horizontally and y meters vertically, modelled by the parametric equations x equals t squared plus 2t and y is equal to 6t minus t squared. So if you want to try this yourself, feel free to do so. But let's start the question. So for the first bit, we want to find x and y values of the position of the disk after 2.5 seconds. So all we do here is just we plug in t is equal to 2.5 in both the x and the y equations. So for A, we would have, so plug in x is equal to 2.5 squared plus 2 times 2.5, and that's just equal to 11.25. And then if we plug in 2.5 to y, we would have y is equal to 6 times 2.5 minus 2.5 squared, and that would be equal to 8.75. So these are the x and y values of the disk after 2.5 seconds. And then the next part B is we want to work out after how many seconds does the disk reach a height of 5 meters. So for this one, the height is measured by value of y, as that's the vertical. So we just want to work out the values of t when y is equal to 5. So we can just plug y equals 5. So we'd have 5 is equal to 6t minus t squared. So then if we rearrange to have an equation that's equal to 0, so you can bring t squared onto this side. So we have t squared, we subtract 6t, we get minus 6t plus 5 is equal to 0. And then we can factorise this, so we'd get, so we'd get t minus 5 and t minus 1 is equal to 0. So then we can have the two values of t, we can have t equals 5 and t is equal to 1. So after 1 second or 5 seconds, the disk has reached a height of 5 meters. So part C, we want to find out how far above its starting point is the disk when it reaches the point 24 meters. So for this one, we want to find out the values of t when x is 24 meters, and then plug it back into the y equation to find the height. So we can do that. So we could do x is 24 is equal to t squared plus 2t. And if we rearrange to have an equation that's equal to 0, we get 0 is equal to t squared plus 2t minus 24. Then we can factorise this to have t plus 6 and t minus 4. So we'd have t equals minus 6 and t is equal to 4. But over here it says that t can only be in between 0 and 6. So we can disregard the option t is equal to minus 6. So we just have after 4 seconds, it has reached a distance of 24 meters in the x direction. So now we want to find the height. So we want to find out what y is when t equals 4. So y is bt, 6 times 4 minus 4 squared. So it'll just be 24 minus 16, which is just 8 meters. So it will be 8 meters above its starting point when it reaches x equals 24 meters. So that's the answer to the first question. It's really similar to just normal parametric equations. They've only put it into like a real life, real world scenario, but just don't get thrown off by that and just do what you normally do, doing like each step at a time. So let's try another question. Okay, so here's another question, and feel free to try it out for yourself again to see if you understood what to do. So we have a football is kicked from the point 0, 0 on the surface of a flat field. After t seconds, it is modeled as having travelled x meters horizontally and y meters vertically from its starting point, where x is equal to 15t and y is equal to 20t minus 5t squared. So the first bit is we want to try and find the Cartesian equation for the movement of the ball. So what we can do is we can just try and find a value for t. So we can do that using the x equation. So we have x is equal to 15t. So if we do x over 15 is equal to t, then we can just sub that in back into the y equation. So we get y is equal to 20 x over 15 minus 5 x over 15 squared. So that we can just cancel this out. So we can simplify this expression. So if you divide by 5, we get 4x over 3 minus 5x squared, 15 squared, which is 225. And we can simplify this expression as well. So we get 4x minus 3, 45. And that is a Cartesian equation for the movement of the ball. So we have y in terms of x. And then that's the answer for part A. And for part B, we want to find out how far the ball is from its starting point after 2 seconds. So we want to find out how far the ball would be from its starting point after 2 seconds. So first we can just find out what the x and the y values would be after 2 seconds. So if you plug in t equals 2 for both of them, so we'd have x is equal to 15 times 2, which is just 30. And then we'd have y is equal to 20 times 2 minus 5 times 2 squared. And that would just be equal to 40 minus 20, so that would just be 20. So then if you imagine you have like a graph, and you have a point here which is 30 and 20, so this is the point you have. So you have 30 in the x direction and 20 in the y direction, and you just want to find out the distance from its starting point, which is the origin. You can use like Pythagoras theorem to find out that distance. So the distance d would just be equal to 30 squared plus 20 squared, the square root of that, 36.1. So for the last bit of the question is saying that the model is valid for t in between 0 and 4, and you need to suggest why it's not valid for values of t outside the range. Well, firstly, if t is less than 0, then time would just be a negative number, and that doesn't make sense. So t can't be less than 0, as it will be negative. And then if we have t is greater than 4, let's see what would happen if we plug what the values of x and y would be. What happens when t is 4? So for x it would just be 60, but for y, if t is 4, it would be 20 times 4 minus 5 times 4 squared. So that would just be 18 minus 5 times 16, which is just 0. So that means if you increase 4, so let's try t equals 5, then you would get 20 times 5 minus 5 times 5 squared, and that would just be y would just equal to minus 25, and that's a negative number, and you can't have like a negative direction. You can only have like a positive height, as like a ball can't go below the ground. That won't make sense. So any t that's greater than 4, you get negative direction for y, so that won't make sense. So therefore you can only have a value of t that's between 0 and 4. So thank you everyone, I hope this was useful and you now understand how you could use parametric equations in different modelling questions. So make sure you do a lot more practice questions just to consolidate everything you've learned.